because you guys are taking down notes. We are going to grade 7.1 in just a second. Which it looks like, hey, there's one even, but I think a lot of them were long, so it's on the next page. But even as you guys are writing, the book is covering elimination now. But remember with substitution how, see if I can get it a little more zoomed in. I know you know this system to some extent. Doesn't mean you're perfect at it, but doesn't mean you might not still kill seals and not quite distribute perfectly, especially if you're subtracting whole equations. That's why I say make them opposite and then add down, but if you don't make them opposite, some of you will be subtracting, and it's just dangerous. But the book has this huge old chart, yeah? I'm showing it to you, but please, you do not need to write it word for word, right? But what are the big ideas? Big ideas, I thought it said, yeah, in one. There we go. You want to obtain your coefficients, which I already put up here, make them match, right? Make like terms match. I say opposite in sign because I think it's a lot better, easier that way. I just ask first and foremost, especially if everyone's on. Number 2, I say if they're opposite, well, actually the book says it too. They say make it opposite so you can add, but I don't know, some of you aren't going to make them opposite, so you need to subtract. So I'm just going to say be careful with your distribution. Basically is, that's kind of like 1 and 2. And I see you say be careful to distribute. Maybe you'll need to, maybe you won't. Kind of depends. So number 2 might be add, it might be subtract. Basically just get the equations together with something canceling out. Hopefully eliminating one variable. Don't need to solve. So eliminate the variable is the bigger idea in that, not the adding. Back substituting that new term that we've already kind of talked about. You have one, you're going back to find the other one, but as we talked about on Friday, there are lots of different places to put it. You kind of have options. With substitution, you had an obvious place to put it. The y equals or the x equals is where you would go back. Elimination, you just got to pick one. That's why it says into either. Some people think there's like a magical one. Not really. But why does number 5 say check? Do you remember from substitution why we needed to check? Like not just like, okay, make sure you're right, but like we need to check. What could happen? Extraneous. What could happen is we could get extraneous solutions that, remember, we got rid of the ln, or we got rid of the square root, or we got rid of something that would have restricted, and we ignored it. Legally, we ignored it, but we can't ignore it when it comes to solutions. Just check for extraneous. So a couple more seconds before we go grade. If you guys haven't gotten it down, take a picture of it because I'm changing in like 30 seconds. But once again, you do not have to write word for word. Definitely, definitely not. Because some of you were already doing it. It's just a few things like the distributing the negative or distributing the opposite. Maybe adding, maybe subtracting, just depending on what you did. That back substitution, there's not going to be a clear place to put it, so just put it somewhere. Carefully proceed forward and then check for extraneous. What's all of chapter 7 so far? Can you guys figure out what like the overall theme is? We're solving. Solving, what are they called again when you have more than one equation? Not linear, nonlinear, what? Systems. Systems, there you go. Yeah. It's some sort of system that we're trying to solve. Which, depending on the situation in like business applications, I guess, or econ applications, or even physics applications, you're going to see some with like free fall models, with gravity and velocity and stuff. It's typical that you have more than 2 equations, but we're starting off with 2 because we're just making them messier with quadratics and different things. So you're like, oh wait, this whole like system elimination substitution thing works for other things than just lines. yes, and even other things than quadratic. So we're kind of starting with pairs, but we're going to build up to groups of 3 or 4 or 5. But when we get to 3 or 4 or 5, like, holy cow, I really hope we can use technology to help us, aka our graphers. Kind of, you see matrices coming. They don't really like fully come until chapter 8. But yes, eventually we're going towards technology. But here's something different. When you guys did matrices last time, with Mr. Che, yeah? When you did matrices last time, it was kind of like, hey, here are matrices, let's talk about the fundamentals of them. And Precalc, it's kind of like, okay, matrices are great and all, but where did they come from, to some extent? How did the programming work, without like teaching you like coding? How did the programming work? How is there like this system that you can tell a computer or calculator to do that will solve these systems of equations when possible? And if not possible, how can you still interpret what it gives you, even if it's not like a nice, pretty answer? Anyway, that's like a future question, technically in chapter 8, but a lot of things that we're doing are building the foundation to kind of understand what the calculator is going to tell you and why and how and where the systematic approach came from. What the math was that went into the programming that made the calculator able to do that for you. So pre-calculus, pre-future everything math, it's kind of introducing coding and programming a little bit, not the computer languages, but the math and the process of being able to use the tool or program or tell the tool what to do, meaning your calculator or even computer. So anyway, all that to say, we're going to this next page is going to seem a little weird. Possible operations. You're like, why are we even going to write this? I'm not going to make you right now. We're going to come back to it before we do some examples and pick up here. But it's because we're kind of introducing what's legal for us to do as humans with our like creative brains and our ability to be like, hey, this way seems easier. I'm going to go this way, as opposed to a computer that's like, no. I need something that's going to work every time. Program me to know how to deal whatever crazy stuff they're going to give me. Anyway, we're going to kind of have this tension in the next 2 chapters of, but I'm a human, I want to do it this way. But yet, wait a minute, we're trying to learn how to develop or create or understand a system that tells a computer that doesn't care what kind of numbers or what kind of approach. It says, whatever, the math isn't hard for me. I just need a way that always works. Think about it, guys. If you were computers, why not just teach you the quadratic formula and forget factoring? Why ever do factoring? If you're a computer, hard numbers with square roots never scare you. Just tell you the quadratic formula. But you're not a computer. You're a human, and you like having easier, more efficient ways to spend your time or to solve. So anyway, there's always this tension of, yeah, we have technology. It's cool. Let's just learn how to use it. But technically, that would always make us jump to the harder math, the more complicated math that always works, that computers are like, just give me what always works, as opposed to humans that are like, but wait a minute, there are more creative, efficient, interesting, maybe even faster ways to approach it, or ways that make more sense to your brain that might not make sense to other people, at least not as easily. So anyway, we're going to deal with that tension a little bit. But first, section 7.1. Sorry, just a foreshadowing, because elimination substitution, like, seriously, you can learn it again. It's kind of building into matrices, but also kind of thinking about computer programming a little bit as far as like the actual math that goes into some of the stuff. So I know number 4, break even. We talked about it in notes. Hopefully you found that super easy, but we have a lot more evens and they're all down here. Number 6 is you guys look at your work on your paper. Hopefully you have yes, no, yes. Yes, no, yes. But what was the math that was required? That's a really weird math question. Yes, no, yes. What the heck were they asking me? Yeah. You're just plugging in and asking yourself, does it fit? But why is there so much math on this page? They didn't do mental math, number 1. And number 2, in order for it to work in the system, it has to work in both. But were they tricky on any of them where it didn't work in one, but it did in the other? Oh, no. There was one of them like that. So anyway, technically you're supposed to be plugging into both, which is why there's so much math on this page. But these ones, they only plugged into one, and as soon as it fails, it's like, okay, forget it. It only has to fail in one to fail the whole thing. Which there's a whole logical component to that, but we'll skip it for now. Okay, guys, see number 10. Hopefully you don't have near as much work as they do, right? Because aren't they like delineating every single step in that huge old table of the substitution, what they're supposed to do? Like, hopefully you don't have quite as much math or quite as much work, but did you still think through the process of the easiest way to substitute would probably be solve for y and plug and chug? You do have a cubic, which is messy if the 2's didn't cancel out, but since they do, quick factoring gets you, but I can't factor. Well, you can. It's a plus or minus square root of 3. And as soon as you have 3 x's, how many points of intersection should you be looking for? All 3. Could you have gone to your calculator? Like in theory, yes, you just would have had decimal answers. Number 1. You would be banking on the fact that you have a calculator on the test, which is only half true. You guys caught that, right? Only half the test, so part of the test will be calculated. But this one wouldn't have been hard. Solve for y and both, find the intersection points. Just would have been decimals instead. Number 26, I feel like this one comes from words. Is this one of those like 4%, 6% things? Yeah? Some of you might have gotten a little bit stuck on what's going on, but this is a great intro to word problems with systems of equations because the situation they gave you, if I remember right, is that you were investing $12,000. How does that sound? You were investing $12,000. That's one constraint. You only are investing $12,000. That's how much money the 2 accounts add up to be, at least as far as the initial deposit into both. But then they also told you about interest. 2 clues, 2 equations, and then ultimately 2 unknowns about how much money is in each account. 2 clues. How much money? $12,000. How much interest? $630. Wait, about that interest. Oh, okay, good. One was 4%, one was 6%. So the money in the accounts, the initial deposit was $12,000. Those initial deposits multiplied by the interest was $630. Boom, 2 equations, 2 unknowns solved. But did anybody do elimination? You didn't have to. But did you? If you didn't, think about section 7.2 and how it's going to be elimination. What could have made your life a whole lot easier if you were doing elimination by hand? If you have decimals? Come on, you're humans, you're creative. We just talked about this whole efficiency thing. Your creativity, your desire to be efficient. Makes a difference. Could you multiply everything by 0.04? Yeah. But ew, who wants to multiply that by 0.04? Could you multiply everything by 0.06? Yeah, but once again. So what's another way of doing it? If you were to use elimination. No? Really? Oh my God. But that sounds messy, right? I mean, you're using legal math, like divide will get rid of, but what else would get rid of besides divide? Why multiply by 100? Don't you then have 4x plus 6y is equal to 100, just adds, right? You don't have to be a computer. You don't have to stick with what's given to you. You can actually play around with it. You can think outside the box. Which I know you're like, duh, it's math, whatever. But in life, man, it's helpful if you can look at the situation and then kind of rework it, rethink it, look at it from a different perspective. But then what can I do to the top once I have this one looking at least a little bit better? Sure, -4, right? And then -4, no big deal, it's -4y, and then -4 is just -48,000. Maybe it's not all that bad to do on your own. Wait, 1, 2, I missed a 0 somehow. By 100 would add 2 decimal places are 2 zeros. Then all of a sudden that cancels out. That's just 2y. This ends up being, okay, quick subtraction, but 2 makes 50, and then 10 makes 60, and then 3 makes 15. Or I should say. I do it the wrong way. Yeah. 2 makes 50, 10 makes 60, 3 makes 63. So 2 and 10 and 3 is 15,000. 7,500. Boom, there it is. Take it, substitute it, and be like, sure, I did substitution. I don't know. I mean, maybe you guys love doing this whole decimal thing, or maybe you love going to your calculator, but I'm a lazy bum, and if I don't have to go to my calculator, I don't. But again, that's the mental mather in me, which some of you don't like mental math at all. But number 44 gives you 2 strict equations. I think it said something about use the graph. You have a circle centered at 0, 0 with a radius of 5. Talked about that on Friday. This guy is centered at 8, 0. So if you had graphed it semi-carefully, square root of 41 would have kind of stumped you unless you realized it's between 36 and 49. So it's 6 point something something. But it probably would have been hard to see the actual intersection points unless you kind of started plugging in 1, that doesn't work, 2, maybe 2, maybe 3. So I'm not sure, once again, like I said on Friday, I know they're saying solve it graphically. I know that you should be able to see it as far as 2 circles. There are going to be 2 answers, but as far as solving for it, it is kind of messy, to be honest. I wouldn't have even used the graph because I'm lazy. Lazy? What? I'm lazy too. I go to my calculator. What did we talk about if you tried to go to the calculator with this without using some online cool thing where you can plug it in without y by itself, like Desmos or CalcChat? You guys would, if you were going to do that, you'd just be lazy and go all the way. But what would be hard about putting this in your TI grapher? So y equals plus or minus the square root. There's y1, there's y2. Oh my goodness, he has 1, 2, y3, and y4. Unless you're smart, then, oh wait, bummer. I need the top of both of those to get that one. I need the bottom of both of those to get that one. Oh, but there's symmetry. Maybe you would have only have had to have done. Once again, you're humans, you're creative. Yes, you make mistakes too. You're scared of picky numbers, but still. You can use your creativity and your, to some extent, ingenuity and understanding of the math to be like, wait, if I find that one, I bet I found that one without having to do y1, y2, y3, y4. Could have been creative that way too. But elimination, you could have gotten x squared minus, if you're not scared of the algebra, I know, it all just moved. Bummer. That's why I don't like writing in Microsoft Word. And if I try to hit undo, it's not going to help. Where'd my problem just go? Up here? Party pooper. Yeah. There. If I subtract, what did I get? 25 minus 41? 5, 10, 16? I really wish we could square root both sides, but we would definitely kill some puppies in the process. But the nice thing is, if you guys can foil not too badly, and you're careful of distribution, your x squareds go away, which is pretty cool. Careful of that distribution once again. But 16x minus 64 equals 16. We end up with, what would that be? 70, 80? 80 divided by 16 is equal to 5? Did I go the wrong way? Plus 64 minus 64 equals 16. I think we even factor out a 16, right? So factoring out a 16, then we could divide it to the other side. That would be 1. So x minus 4 equals 1. So then plus 4 is 5. That's not good. Did I miss something in my math? I might have. Well, so much for my doing it by hand will save you time. So do better knowing mental math. 25 minus. Oh, negative 16. So that makes a big difference. Someone's excited. Oh, come on, man. There's some extra
Yeah, it's late, sorry.
70, 80, 80 divided by 16 is 5. Well, something went wrong with my math. Sorry, guys. I'm not sure what it is. I don't hear anyone out there catching me on it. It should have worked out nicely. 5, 10, 16. Plus 4 minus 16. Oh, I didn't change my negative. Got it. All better. I changed it there, but not the other one. The screen messed me up. So then when we add 64, we actually end up with 48. 48 divided by 16 is 3. X equals 3 is the single x component, but when I go to plug in x equals 3, I do get a plus or minus square root of 16, which is plus or minus 40. That little negative. One little thing can throw you totally off. There we go. That would have worked. But now we're down to, I think, the last couple, 60 and 62. 60 was a wordish one. 62 was just a calculator-ish one, because you were looking for the break-even point is cost and profit for a business. But the intersection can also be the market equilibrium, which is very similar to what we say at the intersection point. But this time we're talking about, I believe, supply and demand. This is an econ term right here, with supply and demand. That one was kind of just like, hey, let's graph both of them as y equals and find the intersection point. But look at this guy. You would have had to play with that zoom quite a bit. Not with the y, but with the x, you would have had to zoom out. This guy was harder because of the words. Because straight commission, if you're making 6% of sales, that's where this one comes from. Like, oh, you're making your salary based on 6% of however much money you make in sales. This one, if I remember right, well, I can tell by the math too. You make $500 even if you sell nothing. But if you do sell something, you only make 3%. So they were asking, okay, well, when is the 6% a better deal? Because if you don't sell anything, this one you at least make money. This one you make nothing. So how much would you have to sell? So that's the intersection point. And this one, a quick elimination is probably the easiest way to go. Or they just set them equal to each other, a substitution, which is why it's in 7-1. You would have to make $16,665. You'd have to make this much in order to make a 6%, actually more than that, to make this type of salary better. But like if you're selling cars and if it's on like a luxury car lot, well, okay, that's just one sale, right? If you make one sale, sweet, just go for commission, you'll make more. And yes, a little bit of a gamble if you make no sale. Or if you're selling houses, like, oh my goodness, sell one house, make one sale, which sounds easy. It's not necessarily, I'm not pretending like real estate is easy. But if you were selling something like, something that's a lot cheaper than houses and cars that works on commission. If you were selling like Bath and Body, I don't know, they always ask you for like, who helped you today? I have no idea if that has anything to do with their commission or their like rewards. But if you were selling something like that that's way smaller, like the makeup counter at Macy's or something, like, I don't know if I want to go for $16,000 of sales every month. Bad idea. But with that, we're done. Is there anything you guys need me to go back and look over at all? I think the word problems were probably the trickiest. No? The substitution is supposed to be easy. In theory, yes, but when it gets applied to harder problems, especially like, oh, we're setting up the problem ourselves, and then you get like interest and percentages, and it can get a bit messy. And you guys just watched me totally make a mistake because I didn't distribute a negative. I killed a seal, and it took me like 3 minutes to figure it out. So just be aware. Mental math, things are going to happen. Mistakes are going to be made. And you could just problem solve your way through it and kind of grapple with it and be stronger as a result, or you could totally just zoom over to couch chatters later and be like, yeah, I don't really care, and then not throw it all. Technically a choice. Obviously there's a Y zone. Hope you make that choice. As we get to section 7.2, I already talked about elimination. We already kind of did on Friday. Reminded you of the general idea. But this page is kind of, once again, getting us closer to matrices by saying what's legal when we're playing with a system. If you only have 2 equations, it's like, meh, what's the big deal? Once again, if you have 3 or 4 or 5, yeah. If you have 3 or 4 or 5. Some of these might mean the difference for you, human, creative, think outside the box. Some of these might make the difference between a really, really hard problem and a much simpler approach. If nothing else, I think at least we can all agree that if it's possible, we would rather the simpler. The computer says, meh, I don't care. Just give me a system. Fractions, decimals, I can handle it. But humans, is there a way to make it easier? Not always better, but sometimes it is. So if you don't like the top one being the top one, make it the bottom one. If it's like 3 or 4, if you don't like the top one being the top one, make it the third one, or bring the bottom one to be the top one. We can interchange equations. That's legal. You guys already know we can multiply an entire equation by a non-zero constant. We can multiply by, like Sadi brought up, we can multiply decimals by 100 and get rid of them if there are 2 decimal places. We can multiply fractions by a common denominator and get rid of them. Or in elimination, we can multiply one term by a constant to make it the opposite of the other. But, as you guys are writing this down, if you want to be snazzy and think about a computer and how it can do the math no matter what, here's a question for you. How to make unknowns match. Because it'll be way harder to have a calculator or a computer. It'll be way harder to have it recognize numbers that match, at least in the programming. Way harder to have the calculator recognize matching coefficients. It's way easier just to be like, I don't care what I have. Here's how to make it match. So what if, that's a horrible phrase, I'm so sorry. What if you have no clue what A is, or B, or C, or D, or E, or F? Just getting you guys thinking. What if you had no idea what that was? Because the input, the user was able to, like in that apps menu where there's a lot of cool, like, oh, hey, there are formulas in here that are hidden. Maybe she doesn't know about, maybe we'll find them. Anyway, what if there was one for solving a system of equations? I've had kids in the past learn how to program their calculators so they can make a program that'll do it for them. Creative. I go through and give them a different calculator for the test, but still, creative. And worth the exercise. How could you tell the calculator to make it match and eliminate? Some of you are like, substitution would be easier. Just say y is equal to negative ax plus c divided by b, plug it in. Well, how do you tell the calculator to plug it? Maybe that'd be harder. How can you make 2 unknown coefficients always match? What do you want the calculator to go for, the x's or the y's? We could. I just said we could make y equal to negative ax plus c all over b and then put it in. They didn't tell the calculator how to solve it. Might be kind of gross. But you could like factor out an x, get it all to one side, have it pop that out. It'd be easier to do elimination as far as the programming or as far as the mental math. But how could you make it where they always match? And I gave a hint. You have to figure out who you want to match. Do you want the x's to match, the y's to match, or the constants to match? It's your choice as a programmer. No, like literally, just choose. Who do you want to match, x's or y's? Okay, cool. If you want x's to match, could they both be 4 right now? Sure. Could that be 2 and that be 4? Sure. Could this be 3 and that be 2? Sure. What could you tell it to do that will always work? How much do you actually understand the math in a way that you could tell a computer the same thing to do every time? doesn't matter what they give. If you multiply one by one and the other by the other, the opposite other, that one will be AD, that one will be negative AD. Guess what's going to always happen? So then couldn't you have your coefficients? Those will just cancel. Those will always go away. And then technically, if you add down, you will know that BD, the y's will be the same, minus AE all of a sudden you just made an equation that will always work. Did you guys memorize that and know what y is for every single system of linear equations? I mean, I guess, but isn't it easier just for your human brains to have like a step-by-step process and do it? Probably. But the computer just says, give me a formula that will always work. Guess for a linear system, if the solution exists, what you can always do. Interesting. But do I make you guys memorize that for how to solve a system of two equations? Heck no, just make a match. Come on, you're humans, don't stress. For a computer? Now there is AI, I'm not pretending that there aren't computers that probably couldn't. I'm just saying for things like your calculators or non-AI enabled machines. So anyway, moving on. You're humans though, you're humans. Although you're like, wait a minute, so this one could be times -1 and that one could be times 3 and that'll always cancel. But in this one, those don't match. So we'd have to make like columns for each different type of term if we went beyond lines. So that gets even harder now that we have e's coming in and we have quadratics coming in. Sorry, let's leave the computer realm for a second, or the whole idea of a system or a way that always works, and use your creativity. What do you guys want to do for number 9? If the answer is substitution, that's great and all, but we're supposed to be practicing elimination. So multiply the whole top thing by -3, the bottom thing by 1/3, -1/3. Sure. And why am I not bringing in the y's at all? What's true about them? Yeah, one's a squared, one's a single. It's not going to work anyway. Yeah? Since we're humans, we're able to make it match really quickly. It's like no big deal. If you're good at mental math, maybe you could do a lot of this in your head. Just be careful, as you saw me do, not on purpose. It's really easy to make mistakes. But please be aware. If your terms don't match, if they're not like, you have to keep them separate. It's a bummer. And that sometimes you're going to have to do some factoring, especially if you have quadratics, but then as you guys also see right down here, we're going to still be using our calculator at times in order to solve.
Wait, what? How do they?
It's a class late. Yeah, better. All kinds of fun. Only a little bit of bitterness. It's all right. Okay, so number 19, if I were you guys, this one we'd have to factor if you use the quadratic formula. Sadly, 3 doesn't count. That's a bummer. This one, why they say elimination? Well, it's not pretty, but those y's could cancel if you add down. It's just going to be a little bit of a party as far as, well, how do I? I guess you got 1 is y1 and 1 is y2. Long story short, most of you can tackle tonight's homework, no problem, but we are taking an extra day, so there must be something coming that we haven't seen yet. This is why I would say that this isn't due until Thursday. Else there is no elimination. Oh, by the way, what I already did today was talking about computers. But it is interesting. Some brains just see like how human brains are moving, and other brains see like, oh, I guess I could have.
What is it?
I don't know my mistakes.
I'm glad to hear that.